I don't have a ton of slides today, but I'm going to talk about, as Will said, how we're talking about soft forks all wrong. So we've been talking already yesterday, and well, James talked about hard forks, but anyway, talking about forks, and we've been talking about them all wrong on Bitcoin. This guy here is trying to think about it right. He's thinking about capabilities, and that's what I want to talk about. So here's kind of the way we've been talking about soft forks. You've probably, if you've looked at soft fork stuff, seen tables like this on various websites like covenants.info or utxos.org or other places on the internet. And there's always like this, oh, we've got some opcodes or some soft fork specific proposals, and here's what protocols they enable or how they help Bitcoin by enabling things. And this is weird because that's not how this works. Application protocols don't require opcodes. They require specific capabilities from the underlying Bitcoin network. So right now, Bitcoin has certain locking capabilities, right? We can lock based on time. We can lock based on transaction signatures using a public key and a private key. We can lock based on hash locks. There's a certain limited set of capabilities for locking funds that Bitcoin supports right now. And that's what protocols need. They don't need opcodes. They need capabilities. And there's therefore overlapping sets of capabilities and opcodes. And it's not just, oh, this opcode gives this protocol, right? That's not the way this works. So here's some examples on this slide of which capabilities some protocols we might want require. Yeah, I'm not going to read all that, but it's up there. I said what I want to say. Similarly, of course, opcodes enable capabilities, not applications. You know, I think we talked yesterday actually about how James O'Byrne's OpVault is designed to be a protocol-specific opcode. But when you get right down to it, what OpVault, as designed beautifully by James O'Byrne, supports is basically a concept that goes back many years in Bitcoin of tap, leaf, update, verify, because OpVault, in order to do the thing, to enable the protocol that James wanted to enable, it has to enable a certain set of capabilities, which includes essentially a opnext output script and op tap, leaf, update, verify. And so with those two capabilities, you get these very ergonomic vaults. But OpVault is kind of the wrong name for it, right? It's actually a two opcode BIP that enables these capabilities, et cetera. So we're thinking about these things wrong. Here's some more examples of that other than OpVault. I'm not going to read all that. So yeah, when we're talking about what we want to do in Bitcoin, we can't have an effective conversation if we're trying to go directly from opcodes to application protocols. That's just not the right mapping. We're not in the right design space. This, by the way, is not my idea. If anyone knows Yuval or Not Nothing Much on X, this was his idea. And I'd been kind of thinking along these lines, but not in the right words until I talked to him. So he and I had a long talk about this, and I totally agreed with him. And so I put it into this talk. All right. So yeah, opcode to protocol thinking leads to magical thinking. And that's kind of the crux of what I want to talk about here, is if you try to say, I want an opcode that enables this specific application protocol, it's very easy to start thinking about the magical thing you would want. If we had rainbows and unicorns everywhere, you would want some thing that exactly solves your problem. And that thing you want may or may not be practically realizable. There may not be a possible opcode that would do that. But when you're thinking, I want this opcode, it's kind of easy to fall into thinking we can design an opcode for this. And when you break it down to what you want Bitcoin's scripting to be able to be capable of, you start to get to more concrete, exactly what is this magical opcode I was trying to design, trying to enable? And that starts to refine your thinking. So I would say that trying to think about capabilities instead of opcode when you're designing an application protocol is a way to make your thinking more concrete and avoid that magical, I just want it to, magically make sure that the value flows from this person to this person. Well, of course, Bitcoin can't do that because that's not within the set of capabilities you could put into a Bitcoin script. Bitcoin doesn't know about people. And that's why this, I think, is very important. Because if we're going to, as I think many of us here want to, if we're going to upgrade Bitcoin and add capabilities, we need to have everyone, well, I shouldn't say need. It's helpful to have everyone thinking in concrete, realistic terms and not getting off into magical, but I want the ponies thinking. That's not going to get us to a concrete, implementable protocol. Oh, yes. Here's some examples of that magical thinking. I don't want to add this until this comes with this magical thing. So I've heard some people say, I don't want to add a covenant to Bitcoin until it enables endogenous fees for second layers. Endogenous fees, if anyone doesn't know, that's the idea that you could have the UTXOs that are bound into a second layer also be used to pay for fees when you're resolving that second layer back onto the main chain. And well, that would be lovely if we could have the fees for resolving onto the main chain come straight out of the UTXOs that are involved in the second layer. No one has been able to concretely describe the capabilities that would enable that feature, and I've asked. So the magical thinking that people get into here, like, well, maybe TX hash would do that. Okay, but what capability of TX hash is going to do that? And just maybe it would do it. So that's the kind of thinking that I think we need to avoid. Yeah, solving impossible problems. You know, I want to solve. Another example would be I want to perfectly solve unilateral exit from protocols. Now that one, there may be some capabilities that would enable unilateral exit. I want to be clear. I actually have a slide that mentions it, but without getting concrete as to, I think we can solve unilateral exit with these specific capabilities, you're still over in magical thinking land. Yeah, and then of course I put it in a somewhat block streamy color because let's wait for a more comprehensive upgrade because we're all gonna switch to simplicity scripting, right, guys? Sorry, did I say that out loud? So here's this is very, very hand wavy right now, but I'm starting to try and put together some mappings of opcodes to capabilities and then protocols to what capabilities they require. And this table is not good yet, by the way, but it's the start that I've put into it so far. And one thing that I kind of, the way I've color coded this table is the dark green is this opcode directly provides this capability in an ergonomic way that you could actually use for something. The light green is this provide this capability, but in a way that no one should ever use, Reindal. And then the pink or red is it doesn't do this. So when I look at this, I personally look at the rows in thinking about combinations of opcodes that have the most dark green. And personally, I actually dislike light green more than I dislike red because I really don't want to be enabling things on Bitcoin that are going to lead people to do things in ugly, non-ergonomic, hard to debug ways. We've talked, I mean, all over Bitcoin X, of course, people talk about, are we going to Ethereumize Bitcoin if we add this or that capability? And one of the properties of Ethereum that I think some of us subconsciously, some of us consciously are against in Ethereum, one of the things we're against there is that you have to audit every single contract, and it costs sometimes hundreds of thousands of dollars to do a proper audit of an Ethereum contract. And we don't want that in Bitcoin, at least I certainly don't. And if we're enabling these light green things, that's the kind of thing we're going to end up with, right? That's people are going to have to go and audit 120 screeching cats in order to figure out what a contract does and whether it has weird edge case holes. So I really want to be doing the dark green things. So obviously, I'm the author of the Ellen Hans proposal for Bitcoin, along with, and that's there's a lot of dark green on the Ellen Hans row, and then if you add check contract verify, the row gets pretty full of dark green. So this, I mean, obviously I'm biased and I made this table, but I want people to work on this with me. I want us to really start mapping the capabilities of the proposals we're making, so that we can see what we're actually getting out of them. You know, are we getting useful capabilities when we add some opcode, or are we getting kind of meh out of it? So that's my little table of capabilities for codes. And then we're going to do the next one, which is how does that map to protocols? So same capabilities across the top. And now which capabilities are required or helpful for different protocols? And one of the things about this is that once we start thinking about capabilities, we can also look at how, well, if we don't do this, do we prevent some application that maybe people think could be harmful to Bitcoin's long-term incentives, right? I don't have strong opinions about this. Some people do. Some people would say that Bitcoin having automated markets or decentralized exchanges would be a bad thing and it could harm Bitcoin's long-term decentralization. If you think that, then this is a very important table because automated markets and decentralized exchanges require certain capabilities. And if you don't provide those capabilities, you aren't going to get automated markets and decentralized exchanges. So at the same time as you're looking at what protocols do I get from this, you can look at what protocols do I not get that I maybe don't want. And again, this is very early. I'm positive that some of what I put on here is wrong because I literally made this specific slide in the hour before the conference out there. So, but I put in orange the ones on this that I specifically want to see improved. On this table, by the way, green means the capability improves the protocol, and the light green is improves, and the dark green is required. I should have said that up front. And so, again, looking at here is where maybe would be the intersection between the opcodes that give us dark green things and the protocols that require those dark green things that we want. And again, if we kind of combine these two tables, we'll see that the kind of CTV plus CheckSigFromStack gets us the dark greens required for, I think, all of the oranges on here. I didn't actually check that before coming up here and talking, but I think it does. And that's why I'm trying to go backwards to why are CTV and CheckSigFromStack gaining so much momentum in the kind of mind share of Bitcoiners. And I think that's why. We haven't been talking about it very well, which is why I'm up here talking about this. But I think that's why, is that if you do something like CTV and CheckSigFromStack, you get the capabilities in dark green, nice ways to use that enable the protocols that people generally say, yeah, we want those. We want these better second layers that offer unilateral exits. We want better vaults, right? And so there's not complete mapping because I'm also probably bad at talking into microphones, so sorry about the sound quality. So we want organic vaults, but that one is not there from just CTV and CheckSigFromStack. But if we do check contract verify too, we fill in that input-output column as well. So anyway, that's pretty much what I wanted to talk about. I wanted to leave time for questions. I think I have, because I want to have a conversation about this. I want to hear interactively what you all think.
I love this mapping of capabilities, but at the end of the day, it comes down to people. Have you considered that with the capabilities, you could overlay that with the Covenant Wiki page of who supports what and get a mapping of who specifically supports which capabilities, and then you can ask them directly and fill in those spots in the grid?
That's exactly kind of where I want to take this. I want to kind of get Floppy's tables on the Covenant on the Bitcoin Wiki is great, but I think we need to start also getting kind of a yes, no, indifferent on protocols, because like I said, some people are very against automated markets. I don't care. I'm indifferent to automated markets. So I want to start getting that mapping as well of developers out there. What protocols do you want to see available on Bitcoin? And then, okay, given that, we don't even have to ask the question about the opcodes, really, right? Once we know what protocols people do and do not want, if we do this mapping correctly, we can say, okay, here's the opcodes that get people what they want and not what they explicitly don't want. And so, it is much easier to ask people not what capabilities they want or what opcodes they want, but instead, what applications do you want? And then it's almost a software problem to just figure out what opcodes get that set of things.
Yeah, I think if you can make that up on a website that's intuitive to just click on each square and find out who supports which thing and why, I would love that.
You want to help me do it?
Appreciate your talk. I have just one question. For things like automated markets, I know you're not worried about that, or whatever you're worried about. Let's say you're worried about something up there. What would you say to the idea that degens don't care about slightly trusted bridges? I'm just going to, sorry, BitVM as like a slightly trusted bridge, there's minimal, is trust, but it's like, maybe it's a nice spot. and it does enable all those things in some roll-up fashion. So how do you think about that when it comes to capabilities, if at all?
Yeah. I think we've come to a place in Bitcoin, thanks to BitVM and the horrors of Collider script and things like that, where the real truth is that anything is possible with sufficient kind of minor trust assumptions and or cost going into it. And that does make this difficult, because are we really enabling that capability, or are we just taking it from you have to do a lot of trust or invest $1 million in hashing to get there into you can do it with just an opcode? And I'm not quite sure, honestly, how to deal with that spectrum that we're on. Degens don't care. And the other thing that I can say about that is that because the degens don't care about certain minor trust assumptions that come in, or accepting a little bit of trust to get what they want, we kind of shouldn't worry about that. I mean, that's my opinion, that we just don't worry about what the degens are going to do. They're going to do it. What we want to do is we want to make using Bitcoin for fuck you money, the correct use of Bitcoin. We want to make sure that is as ergonomic as possible. And so that's kind of my focus when I look at this. I'm trying to get the FU money purpose of Bitcoin as ergonomic as possible, without regard really for what happens to the degens.
Hey, so I definitely think like approaching things from use case over opcode design is the right way to go at things. But like, what are your thoughts in terms of analyzing like comparative cost and efficiency per use case based on different opcodes? Like, you can get the same functionality many different ways, but how does that actually play out in terms of the on-chain footprint and profile and economic cost based on the specific opcodes you use to implement some functionality, and how that should be kind of taken into consideration?
Yeah, I mean, you have often said to me that we should stop byte pinching. And I think there's some threshold of kind of byte differences where we just shouldn't care. I don't know what the exact number is. I would say like, oh, if the difference is less than 4 V bytes, maybe 16 weight units, we just shouldn't care. And what I found is that when we go through this and we look at things that are actually ergonomic, it's relatively uncommon that there's more than a 4 V byte difference in using different things that are all ergonomic for different protocols. An example where there is a more than 4 V byte difference is right now we're talking mainly about CTV as a way of getting a transaction hash onto the stack. And because CTV is a verify opcode designed for NOP usage, it does have a 8 V byte cost that is not always required. So maybe that's a place where it might be worth optimizing that, as I think InstaGibbs has suggested that we should have an op template hash that comes along with it that just pushes the stack and saves those 8 V bytes. So yeah, I think it's somewhere in that range. There's some threshold where we just don't care. Oh, it takes one more opcode. No one cares. But it takes a whole other hash. Maybe we should be caring about those differences. Or we should just activate Goldie blocks. So since you said that, I want to say that I retweeted actually while Jameson was talking. I said something similar to Jameson a year and a half ago. I agree. At some point in the distant future, we're probably going to have a dynamic block weight, because we're dealing in a market system, and we don't have right now a way for the block space to react to the market. I think the error that has happened in the past on Bitcoin is thinking about block size changes before there even was the possibility of a market for block size. And I think we may still be in that era, because the subsidy is so large, we just cannot tell what that should be, because right now the subsidy pays for all this hash power, and that prevents us from detecting the actual market value of these things. So since you asked, I get to say that little comment.
I'm just going to make some unreasonable demands. Don't worry about it. But can you make me a mevometer, like something that measures how much mev you get from all these opcodes if you combine them?
I think that's a great idea.
The other would be just there's lots of different opcodes there, and some projects are like a great whatever. I'm trying to get an idea of how many lines of code you want to start adding to consensus, sort of that stuff. That's probably another chart to look at, because maybe 10 codes combined is nicer, but it's like, okay, now you've got 10 opcodes that two people need to review. So anyway.
Yeah, I think that's another dimension to compare opcodes on. We also, so I would say we can probably do a pretty good mapping of which capabilities enable how many types of MEV. A reasonable proxy for that is things that enable decentralized exchanges and automated markets broadly are likely to enable many modes of MEV. There's not a perfect mapping, but it's close. So that's the best proxy I have in these slides, which is one of the reasons many people in Bitcoin are so against those things, is that they're very concerned about MEV. Again, I personally am not, but I understand the concern. Regarding the complexity, there's been a lot of talk, as I'm sure you're aware, but I'll say it out loud anyway, of kind of the complexity of reviewing kind of a narrowly scoped opcode that does one specific thing versus kind of a more complex opcode. An example is both check contract verify and vault are a fairly kind of somewhat omnibus opcode. They do several things inside of the opcode versus CheckSigFromStack is a single purpose opcode. And complexity of review scales non-linearly with both code size, and how much is happening inside of the opcode. So I would speculate that several small opcodes are actually less reviewer time and effort than one large complex opcode. So it's a bit hard to make that distinction.
I guess I had a question about, I guess, activation. My understanding is obviously there has been a soft fork in some areas now. And then when there is a soft fork proposed, there's a year-long something activation process, which implies that you essentially could only do one, maybe a year or every couple of years. Is that true? How do you think about combinations of codes and soft forks, et cetera, upgrade paths?
I am very far from an expert on activation. It's not a thing I think about a lot. I would say that my personal thinking on Bitcoin is that when consensus is reached on doing something, the activation is the least interesting part of that point. As far as I'm concerned, for soft forks, it would be perfectly acceptable, for example, to just do a flag day. Forget the whole signaling and 6 months and a year, whatever. These are soft forks. We already have kind of broad consensus in the technical community. Just do it. Now, others disagree with that. I'm not saying everyone agrees with that. It's my opinion. And so I want other people to have these discussions about what activation paths might work. I think it's fine to combine opcodes. I think it's fine to do separate activations. I think you can have overlapping activations. Like, you could have the signaling happening for signaling for another soft fork happening during the activation kind of pause for another opcode. Like it doesn't actually matter that much to me, because what we're trying to do is build technical consensus around these things. And once that is reached, it doesn't matter how we activate them because we already reached technical consensus on it.
Yeah, I appreciate the, as Shinobi said, the attempt to focus a little bit more on the use cases. I do want to ask you, you were at BTC++ last year in Austin, I believe, right? Yeah. And there was a couple of presentations, notably from two people from the same company, Christian Decker and Rusty, who I think introduced a new bend in this entire conversation. And if I can summarize it, it was sort of introducing perhaps an approach to soft fork that goes in a different direction than what the piecemeal sort of like incremental narrative that has been dominant in the space. And, to Christian's point, I think was more so like, why don't we approach this from sort of perhaps, or even Rusty's, like sort of like a Manhattan style project for Bitcoin, where we actually stop trying to go at the bargaining table every year and argue about and bike shed and horse trade about which opcode is going to make it in, and have a sort of like larger scope vision about exactly what we're trying to achieve. GSR is one example. I'm not saying it's the right one. There's sort of like, obviously, like Blockstream simplicity. There's Lisp stuff that AJ is working on. I just want to get your take on like, what is your opinion of like this type of direction?
Yeah, Austin, as you know, I was big into what Rusty had to say, and that, I still am. Like, I think that the restored script that Rusty envisions is a good long-term direction for Bitcoin. I said it to Rusty there, and I will continue to say it as long as I'm talking about Bitcoin. I think a more incremental approach is the right way to go. But what I actually appreciate about that kind of more, here's the glorious future essentially thing, is that it helps us give a direction to what we might do in the meantime. So when in talking about restored script, it was very clear that restored script would include something like CheckSigFromStack. So if we start adding those things incrementally to Bitcoin right now, what we're actually doing every time we add something that's going to be in restored script anyway, we're de-risking that future. And so we're both concretely improving Bitcoin right now today, and we're de-risking the future. And if it so happens that we develop CheckSigFromStack and TX hash and the SigOps budget and all the VAROps budget, we develop all those things and we don't actually do a soft fork during the time we're developing them, then maybe they all activate together as restored script. But still, development and even preparing and trying to activate incremental things in the meantime is still, I think, the right approach.
So from that perspective, you think there's like an opportunity to kind of like package this story to users in the wider ecosystem as this grand scheme that we're trying to achieve, and that we implement in an incremental way, so that there's sort of like a larger scope vision, right? That everyone can buy in because it seems to give everyone what they need. Therefore, we all push in the same direction without having to kind of like everyone pull their side of the blanket because they want to have what they need now.
Personally, I don't think we can get like everyone on any page. I own the domain everyonewon'tjust.com because everyone's not just going to pull in the same direction. That's just not the way this is going to work. So I think the better kind of mindset is we're going to design a bunch of things. We're going to see kind of almost what a common denominator is. And that's like another reason that CTV and CSFS have so much momentum right now, is they kind of fall out as a common denominator. Oh, you want to go towards restored script. You want to go toward vaults. You want to go toward blah, blah, blah. And CTV and CSFS end up as common denominators for all those different things. And since we're not going to get everyone to just pull in the same direction, instead we need to be looking at everyone's pulling in different directions, but they all pull this one thing in. And then after we have that, we'll sort it out again. That's how I look at it.
Let's give it up for Rearden.